Okay, in this lesson, we're going to be solving square root equations. And so something to remember is that square root is the same as a 1/2 exponent, a 1/2 power. And so if you see a 1/2 power, you can just treat that as a square root. And so we're going to start off with some simple equations and then move from there. But remember that a square root must always be non-negative. So it has to be greater than or equal to 0 because you can't square root a real number and get something negative. So not non-negative is how we say that. It can be 0 or positive, but not negative. And so here, square root of x equals 9. That means x had to have equaled 81. And so you can think of it as squaring both sides to cancel out the square root. And so x equals 81 is the answer to number 1. Here, if you tried to square both sides to solve this, you would get an answer, but it doesn't work. Because if you look at our original equation, it's saying the square root of some number is negative 16. We know the square root of a real number cannot be negative, and so this would be no solution. Anytime you see square root equal to a negative, you can stop and say no solution. In this next example, you can rewrite x to the 1/2 power as square root of x if that makes it look more familiar. And then as you're solving these equations, you want to isolate the radical. And so this -5 is outside the radical. And so we're going to cancel that by adding. And then we have square root equal to positive, so it is okay to go ahead and square both sides. And so x equals 20 squared, which is 400. Next, we need to isolate the radical. And so we have to get rid of this 2 and this -8. Always take care of what is furthest from the radical first. So we have to add 8 first. And so here we had a negative, but it ended up getting resolved once we added the 8. And so now when we divide by 2, we get square root of 1 minus 4x equals 2. Because we have square root equal to a positive, it's okay to square both sides. And so 1 minus 4x equals 4. And then we can isolate the x by subtracting 1 and dividing by -4. And so -3/4 would be our final answer. Okay, when you start having variables on both sides, that's when you have to check for extraneous solutions. Before, we were just making sure our square root wasn't equal to negative so that we actually had a solution. Now, we could end up with a solution that creates a square root equal to a negative situation. And so, first up, we have our square root, and it's already isolated, so we're ready to go ahead and square both sides. And so the square and the square root cancel over here, leaving 21x plus 1. But x plus 5 squared, be careful with that. You cannot distribute the square to a binomial. You have to FOIL this. And so this ends up giving us 21x plus 1 equals x squared plus 10x plus 25 when you FOIL out that expression. So now we're left with a quadratic equation to solve. And so when we solve quadratic equations, we have to get everything on one side. I usually move it to the positive x squared side. And so that leaves me with x squared minus 11x plus 24. And so we want to try to factor. Always try to factor first. And so two numbers that multiply to 24 but add to negative 11 are negative 8 and negative 3. And so this factors to x minus 8 and x minus 3. And so to solve this, we would set each one equal to 0 and get x equals positive 8 and x equals positive 3. Now, we can't commit to these as our final answers until we check to make sure they're not extraneous. And so you check them by plugging it in to the original equation. And so testing x equals 8, I would have square root of 21 times 8 plus 1 equals 8 plus 5, doing the original equation before we squared both sides. And so this simplifies to square root 21 times 8 is 168 plus the 1. 8 plus 5 is 13. That gives me square root of 169 equals 13, which is a true statement. 13 does equal 13. Next, we're going to check x equals 3. And so 21 times 3 plus 1 equals the 3 plus 5. And so that gives me 63 plus 1 equals 8, which says square root of 64 equals 8, which is a true statement. 8 equals 8. And so both of these are solutions. Neither are extraneous. Next, we have x on both sides, so we're going to have to check for extraneous solutions. And this time, we have to isolate the radical first. So this 2 has to move to the other side to isolate our radical. Now we're ready to square both sides. So that gives me x plus 14 equals x plus 2 squared. I'm going to write that as x plus 2 so you don't distribute the square. FOIL the right side, that would give you x squared plus 4x plus 4. It's a quadratic, so move everything to the other side. And so try to factor. We need two numbers that multiply to negative 10 but add to 3. That would be 5 and negative 2. Set each factor equal to 0 and you get negative 5 and positive 2. First, we're going to check x equals negative 5 in the original equation. So we would get negative 5 plus 14 minus 2 equals negative 5. Simplifies to square root of 9 minus 2 equals negative 5, which is 3 minus 2, which says 1 equals negative 5. That is not true. And so x equals negative 5 is an extraneous solution. And so you would mark that out and label it extraneous solution. Next, we're going to check x equals 2. And so I'm going to come up here. Square root of 2 plus 14 minus 2 equals the 2, which gives me square root of 16 minus 2, which is 4 minus 2. And so it simplifies to 2 equals 2, which is a true statement. So we only have one solution, and it's x equals 2. Okay, this next example has square roots on both sides, and so the only thing you can really do is go ahead and square both sides. This one's actually easier because the square root cancels on both sides, leaving us with just a linear equation to solve for x. And so subtract the x from both sides, add 6, you get x equals 9. And you don't really have to check these for extraneous solutions, but it's always worth plugging it in just to verify. And so I would get 18 minus 6 on the left side, and then 3 plus 9 on the other side. And so that simplifies to 12, square root of 12 equals square root of 12, which is true.